All right, guys, here we go with the start of last unit of the year, algebraic trig. You can see, so what we're going to look at today is both some proofs and some solving problems, and we're going to be looking at the sine rule, or sometimes it's called the law of sines, the cosine rule, the law of cosines, and the formula for area of any triangle in general. The other thing is we're going to talk about a specific case of the sine rule that's this condition. So I'm not going to say it. I call it SSA, which is the case where you have two sides and an angle. And this is different, side angle side SAS. This is two sides and the included angle. Okay, when we have SSA, it's a little bit different. So we have two sides and maybe the non-included angle. So maybe we know this, but we don't know that side length. So that's a big difference to understand. First of all, is the difference between SAS, where you have the included angle and two sides that generate it, and SSA, where you have two sides and you don't have the included angle. You either have this angle over here or this angle over here. Okay. So we've got some review here first, and might as well get right into it. So if I want to find the area of a general triangle, right, if I have this SAS case, right, I can basically just use this formula here, that the area of the triangle is equal to 1/2 AB sine C. Okay, what this means is the two sides that you have, okay, they have to form this third angle. So in this case, we have 7 and 11, so I could label those if I wanted to. I'm going to call that A. This is B. That means that this side is C, and that means more importantly that this is angle C. Okay, and the way we denote angles is we usually use capital letters. Okay, so if I've got side A here, angle A would be across from it. If this is side C here, angle C is across from it. And if this is side B, angle B is across from it. All right? But this is pretty easy to do if we have this setup. So I could just say here that the area is equal to 1/2, well, the product of the sides, so that's 7 times 11 times the sine of 30 degrees, and hopefully remember that's also 1/2. So this really ends up equaling, what is that, 77/4. Okay? So I'm just going to leave that as the answer. That's the area there. 7 times 11 times 1/2 times the sine of 30, which is also 1/2. Done. Next one. Solve for the unknown side or angle. So here, I've got two angles, and I've got one side. So we would call this case AAS. Okay, that's when we have two angles but not the side between them. Okay, if I knew this side here, if that was 7, I would denote this scenario as ASA. With this setup, the way we want to work it is we want to use this sine law. Okay, so basically it says if you have the sine of some angle over its corresponding side, so for example sine A over A, that ratio is equal to the sine of angle B over side C, and that's also equal to the sine of angle C over side C. Okay, we also could flip these, so we could also say that A over the sine of angle A is equal to B over the sine of angle B, which is equal to C over the sine of angle C. So you don't have to have all three of them, right? You can just set, for example, maybe A and C together. You can set B and C together. And you can start with all the angles in the top, or you can have all the angles in the bottom. The key is that if you have angles in the top, you got to stay consistent with that the whole time. You can't have angle over side equals side over angle. It doesn't work. So in this case, the way I want to set this question up is I would start with the side. Okay, so I'd say x over sine 80. Well, that's going to equal 7 over sine 60, right? And then we could solve that. I'm going to let you guys do that because I don't have a calculator on me, but I guess I'll just write out that x in this case would equal 7 times the sine of 80 degrees, and we would need a calculator for that. That's not an angle that we expect you to know the sine of, and that's going to be divided by sine 60. Okay, so you guys can work that out. But this is what x would equal, okay, using the sine law. Oh boy, now. Yeah. The other law we have, a rule, is, shocker, it's called the cosine law, all right? This thing looks eerily similar to the Pythagorean theorem, right? We've got a squared equals b squared plus c squared, but here we have this extra part, and it's interesting because if angle A here is 90 degrees, well, we hopefully know the cosine of 90 is 0. This zeroes out, okay? So this actually is the same as the Pythagorean theorem. When it's just that when A is 90, this part all zeroes out. So this is a more general form of the Pythagorean theorem. If I've got that, basically I want to use this whenever I don't have an angle and its corresponding side. Okay, if I have those two things, regardless if I have an angle or a side, I'm going to use sine rule. So really only want to use cosine when we don't have an angle and its corresponding side. So I'm going to write that. So we want to use when don't have an angle and its corresponding side. Okay? So we can kind of see that here, right? Here's the only angle I have, but I don't have its corresponding side. So I have to use cosine rule here. All right, and the way we want to set this up is, let me get a highlighter. Okay, that is not a highlighter. Here's a highlighter. So the angle in the cosine law is A. So that means I'm going to make this angle 97A. If I do that, that means this is side A, and then these don't really, I mean, we could either call them B or C interchangeably, it doesn't really matter. So if I'm solving for A, in this case, that means that A squared is equal to, what would it be? 22 squared plus 28 squared minus 2 times the product of these two times the cosine of 97 degrees. Okay, so to solve for A here, all I'm going to do is crank all this and then square root it. All right. Again, I'm not gonna put that in the video right now, but I will go back and put an answer to this and this in the filled-in notes. Okay, I just don't have a calculator on me right now. Okay. Next thing, and yeah, we'll do these two, and then I'm going to stop the video because that's enough for one. So, proof of the area formula. Okay, so we know, hopefully, that the area of any triangle is equal to 1/2 base times height, but that's on the condition that the base and the height are perpendicular. Okay, here we have that. All right, we have this height, and we have this base. Okay, so I could say here, let's start over here, that the area of this general triangle is equal to 1/2 AH. All right, but the thing is, sometimes we won't always have this. Okay, we won't have this perpendicular height, so we can use right triangle trig to get that. If I look at what I have here, I've got this angle, and this. So one trig ratio that I could write is that the sine of C is equal to h over b, right? The sine of this angle is equal to opposite over the hypotenuse, so the sine of c is equal to h over b. If I solve that for h here, well, I'm going to move the b over. So that means that h is equal to b sine c, and then basically we have the proof, right? I'm just going to take this, I'm going to put it right in there. Okay, so let's say that this b sine c can go right in there. So that means that the area is equal to 1/2 a b sine c. Okay, and whoops, I want to kind of underline that. So we could prove this in another way, right? Just calling the letters different things. So I'll use green. This also, we could say, this is also equal to, well, let's just change the angles. I could say it's 1/2 AC sine B, right? So I've got the two letters A and C, and the angle is angle B. The other way you could write it is 1/2 BC sine A, okay? But this is usually the most conventional one, okay? And it's not too bad of a proof. Last one, okay, cosine law proof. So this is a little bit trickier. And again, what does cosine law say? Well, it says that, hope I set this up the right way. Yeah, all right. So cosine law says a squared is equal to b squared plus c squared minus 2bc cosine A, right? So whatever letters isolate here, I need that corresponding angle isolated here. And if these are B and C, then it doesn't really matter the order that you put these, but these two values that are getting squared have to go here. All right, so how we're going to prove this, I'm actually just going to scroll down and kind of walk us through this proof because it's already printed for us. Well, we have a 90-degree angle, right? That's important. We've got a 90-degree angle here. And so what that allows us to do is write two different Pythagorean theorems. The first that we can write is that this, right, this hypotenuse, this is side A, so that's going to equal this squared, which is h squared, plus just this part, okay, which is, if this whole thing from A to C is B, if that length is B and this is x, this has to be B minus x. Okay, so this equation here is just saying, oh, well, B minus x quantity squared plus h quantity squared has to equal a quantity squared. Okay, let's just leave that alone for now. The other relationship that we have is with this right triangle, right? So this says that x squared plus h squared is equal to c squared. So we have that right here. Okay, now here's the thing. If we take this and we expand out this part, well, this is going to be, b squared minus 2bx plus x squared. It's going to be plus x squared because this negative x, when you square it, becomes positive. Okay, so this part becomes this trinomial plus the extra h squared. And then, well, this x squared plus h squared we just said is equal to c squared. So we could rewrite this part as this. Okay, and the only thing we have to do, because now we have a squared equals b squared plus 2bx, minus 2bx plus c squared. Well, there, I mean, if we just take this and we rewrite it, we can say that a squared is equal to b squared plus c squared minus 2bx. All right, well, that's kind of what we want if we look back up here, but it's not exact, right? We don't want 2bx, we want 2bc cosine A. All right, so let's look over here, this triangle. Well, if I take the cosine of A, it's equal to x over c, right? Let's write that. the cosine of A is equal to adjacent over hypotenuse. If I isolate x, if I take this and I isolate x, I move the h over, right? So that means that h, sorry, not h. That means that x is equal to h cosine A. And now I'm going to take this expression, h cosine A, I'm going to put it right there. Guys, I'm silent because I was realizing something was wrong. I didn't do my cosine right. Cosine is x over c, not h. X over the hypotenuse. So let's go back and change that and actually make sure that this works. So yeah, cosine is adjacent over hypotenuse. So this should be a c, and then this becomes a c. And then when we plug in here, right, this expression right there, we get what we want. So that means that a squared is equal to b squared plus c squared minus 2bc cos A. Nice. So there is our proof of law of cosines. All right. And I'm going to stop the video here so you can take a break. I can fill in the answers, and I'll make a second video for the rest of the slides, which looks like it's a little bit more than half. Okay.